Hello. Today I'm giving this talk the second time. Probably you were on the first one. Any of you? No? So few. So I'm sorry for that anyway, because this is kind of different events, and the topic is about Kotlin Multiplatformity and JavaScript thing, which is front end. So I really wanted to share with both front-end developers and Kotlin developers. Okay. Oh, great. I wanted to do this talk as kind of inspirational talk because Kotlin Multiplatform is a new technology which we are doing for almost 3 years, but it's still new. It's complicated and in experimental state. However, I would like to ask you to try and experiment with such technologies because we require as much feedback as possible. That's how we can do this technology in a brilliant way. So let's start from the beginning. Kotlin actually has not only the single backend, which is JVM. We are able to compile it to JS and native as well. So how many Kotlin developers here? And do you know that Kotlin JS exists? At least. Probably you use it in production. So okay, we have a brave guy who uses, but it's not in experimental state. I mean that Kotlin JS you actually can use in production and use it for compiling into JavaScript. So we have a different backend, and the very nice idea is to actually make it multi-platform and compile into the same code into different backends. But this is after the short introduction about Kotlin JS. So Kotlin JS started as a students project 5 years ago. This is a very usual situation in JetBrains, and they did proof of concept. They wanted to try to compile Kotlin into different backend to check if it's possible or not. But then we realized that this is quite nice idea and continued this work, and now it's quite a big professional team with actually production-ready technology. So what is it? So I want to share you to show example from the scratch in live demo. So let's create new project, which is Kotlin JS for browser. Let's put something here, like sphere.it here. Skip, and that's it. Now we have new project. Let's go to presentation mode to see what's happening here. This is a pretty simple project which actually puts the hello world to the web page. So let's run it just to see what's going on. We can do the terminal and do Gradle view run -t. It means that it's continuous mode, and we can change and see changes in browser immediately. So let's take a look for that. Let's exit presentation mode because we need a browser here. So it's compiling right now, and after some time we see the result in the web page. So that's completely JavaScript. So now we have this in browser. So let's change something, like put here sphere and save file, and not immediately, but after some short time we see the changes in browser. We can do some more stuff like extract it and put changes here, like sphere.it, how it's actually spelled, and here is it. It is, yeah. So let's continue. Enter presentation mode. So what is important when you do something like new backend stuff? You need to integrate it with ecosystem to which you actually compile. What does it mean? So it means that you need to be able to call JavaScript code and to be able to be callable from JavaScript code. So it's like highly interoperable thing. Another thing is that you need to support tools from this ecosystem. So that means that you need to support npm package first, webpack thing, and so on. So let's take a look how we can add dependency to npm package. So here I prepared some magic things. I'll explain you a bit. So here we need to put Kotlin Gradle Properties. So this is actually when we add npm package, then it generates Kotlin externals from TypeScript definitions, and now we can invoke methods from Kotlin like we can invoke any Kotlin code. Another thing, we need to change build Gradle KTS, not KTS, just build Gradle, but we need to add actual dependency. So here Kotlin, let's copy another magic string. So here by source sets, we added new dependency, npm dependency, to the main source sets. So now we need to stop our thing, and now we need to do synchronization of the project just to see the result. So while it's synchronizing, let's do some interesting stuff in Kotlin.js that it's just possible to do any of code. So let's implement, for example, factorial method, which is pretty obvious, but again, we can do it in an interesting way like one-line code. So as it's today, not today, and on Monday it was ScalaSphere, and lots of functional stuff exists in ScalaSphere. So in Kotlin we can do some small things from functional programming. For example, we can do fall. We also could do reduce, which I did on the first talk, so this is a significant difference to the previous talk. So fall is actually means that we can take the parameter from initial value and then take each value from the range and apply some function here. So let's apply function, which is multiplication. So now it's really factorial because we multiply values from 1 to n. So we have it synchronized, and now we can check the function which is left part. So let's do it like iterate over 10 values, and like write document write something like HR. And then let's write actual factorial thing. So invoke a factorial of I, invoke it to string, and then we actually need to use left part here because we want to show them in the aligned way. We can put, for example, 10 numbers and put here 0. So here we really invoked JavaScript code. We can navigate here. Here is actually external dependencies to JavaScript, which was generated. So that was done by that magic property in Gradle Properties. So let's take a look what's happening right now. We are running again. So let's go to the browser, and now we see that it's actually our factorial thing here aligned in the browser page. We also can, for example, change something, save, and see how new lines added. So everything is pretty fast and this is very important for front-end world because JavaScript developers do something like visual coding. So, and me personally, I would prefer this kind of coding as well. Unfortunately, JVM infrastructure don't give the same capabilities. Okay, so what's next? Other thing which is very important is actually tests. As we heard from some talk on front-end sphere, actually not all the NPM packages contains tests, so it's like only 60%. But again, it's still important, and I hope that in future more and more JavaScript packages will have tests as well. So let's create some code here, Kotlin class, and name it factorial test. We can put here some test, which is, for example, test 5. We can expect 120, which is 5 factorial, and actually we can do some mistake here and put factorial of 6. Now we can run tests from Gradle. This is a browser test, and you actually can choose different types of browsers and put them into Gradle script. So you can run tests against all possible browsers and Node.js. So if you run them, you see, if I add them, I'll see all the failures in all the browsers. But sometimes it's different in different browsers, so it's important to test against. So what we have here, we have the reporting. Okay, file is cut here. So let's take a look for him. Here, reports, tests, tests. Here our file with actual results of this test. So let's take a look what's happening. So exactly this test is failed, and we see that expected 120, but actual 720. And it's very simple to fix, just by changing back to 5 and rerunning it. So we will see that build is successful. So that's it. I actually wanted to show how it looks in reality, this JavaScript code. So let's open the compiled code in packages in here, Kotlin, and we can navigate here. So now we can see how it really looks. So this is our function factorial, and here we can see accumulator, which accumulates actual value, and inside of while we iterate over range and multiply things. This is ugly a bit, but it's still readable. So it's a bad idea to use it like converter from Kotlin into JavaScript. But still, you can take a look into this code and realize which possible problems can happen because of in real JavaScript code. And another thing is that we don't see any lambdas here. We actually used lambdas for fold, but fold function is inline function, so all the code was inlined, and this is really efficient from the runtime perspectives, instead of creating new objects for lambdas. So we also can try to call this code from JavaScript, and this is possible by calling this factorial ZA3LPA. What is weird from the first perspective, but the reason is that in Kotlin it's possible to overload functions, and they have different types, and you can overload that, and this is a huge problem. For example, even you can say, okay, if you have one function, why we still do this is crazy stuff? The reason is very simple, because if you add the second one, how we need to recompile that, because names starts to change and it's very hard to understand how to do it incrementally. And the incremental compilation is very important here as well. So the same function should be compiled to the same thing. So that's why the naming is still like that. And how we can fix actually that? We can just define some instruction for the compiler to name it for JavaScript. So we put JS name and export the name factorial. So let's recompile it. And return back to the JS, and now you can see that this factorial thing is any questions? Okay, please.
Why can't we just, in case of overloading, accumulate all those functions into a single one? So like inside, like instead of 3 functions, 1 function, if a subset of parameters is use that one. If other.
Okay, so the question is why not to collect all the functions together by default, I mean, and choose overloading by runtime. So the reason, actually it's possible, yes, you're right. So this requires some reflection library inside of, because we need to do runtime reflection of types to understand overloading. So it requires a bit more things, but at least we probably want to implement this kind for different numbers of arguments. So it's like possible directions for improvements here. But for now, it requires, unfortunately, manual naming for all the functions you want to export to JavaScript. So let's turn to the slides. So that's it about Kotlin.js. I wanted to show in this example that lots of things is possible in the front end, from the front end's perspective. Still, we want to implement more things like tooling in IDE to help people to run not from terminal, just from the IDE, to have a nice view inside of IDE. So these things we are working on, and it will be in the near future. So the next topic is around Kotlin Multiplatform. So if we have different backends, so logically that we can take the same code and compile it more than one time to the different backends. What does it mean? That it will help not to do the code twice. For example, in JVM and JavaScript, it's a very famous thing that you can share data models or some business logic, which can be a validation of forms, or it's also a famous example like sharing validation of credit cards, which should be done twice again on the client side and on the backend side. So original idea looks pretty simple. What if we take the folder and just compile it twice somehow? Actually, it has some problems, because if we don't do additional support, in this case, only pretty basic Kotlin stuff, which depends only on Kotlin standard library, can be really done. So we started to think what we actually need to support real Kotlin multi-platform. The first thing is that we need some additional language support. I mean, for example, if we want to compile to JavaScript, then it means that we can't depend on any Java libraries. But sometimes we would like, I mean that if, for example, we want to invoke and see current time milliseconds, and we can't call like Java system library. But what if we just take one method which is not implemented, And we implement this method only for platforms separately, like separately for JS, and invoke specific method for JS, and separately for Java. So we need some language support to understand these cases. We also need some kind of build tool support because it can really help people to do dependency management and describe such kind of difficult projects. And IDE support also required, so this is pretty simple. But what is the most important that is required is interoperability with all the target ecosystems. So as I already showed around NPM and other stuff inside of front-end ecosystem. What is target? Originally, when we started do multi-platform project, we thought that target is pretty basic and simple thing. It's like JVM or GS or native. But even for iOS, which is another famous example, when you want to share code between Android and iOS stuff, and it's possible because of Kotlin native, it has already 3 targets. So one of them is ARM32 for old iPhones, another is ARM64 for newer one, and you also need to simulate it on your laptop, which is x64 architecture. So that's already a problem, and we realized that we need to do more complicated understanding of target. Also, different JVM versions could be different targets, Android or JDK 9 or even JDK, I don't know, 12? No. And we can think even deeper, like if we have different libraries, JUnit and TestNG, and for example, we want to implement such things like Kotlin tests, we can think that different dependencies is actually different targets. So you can implement all the stuff of Kotlin tests and do the abstract implementations for important things, which leads to actual test framework. And then in the target, you can really lead to these test frameworks. So what is common code? I used this word not once. Common is not just, it can have only common dependencies. And looks like it can be like pure Kotlin ecosystem, which ends to the standard library, but it's not really like that. Because even for iOS, we have, for example, 3 targets. And we would like to have common code for iOS and just some differences or even no difference for these targets. And this means that we need to have something like common Kotlin libraries for iOS frameworks, where we can depend on that. So this is a bit more complicated. It's probably simple to understand already what is expect actual, but this is like new language features. But I like some metaphor about what is really expect actual. If you have a common code and something should be different for different platforms, you can define this is something as an abstract function. So this common code is like abstract class, and in actual platforms you implement this abstract class as a concrete class with real implementation. So multi-platformity is like object-oriented structure of abstract class and implementations. So it even can be more complicated, like abstract class for common, abstract class for iOS, and concrete implementations for concrete targets in for ARM32 and ARM64. As a build system, we chose Gradle one because this is the most popular build system for Kotlin. So we needed to choose any of build systems, so we chose most popular one. And probably in the future we can support more build systems. like Maven, but we need to invest lots of time even in Gradle as well. But what is most important that we need to solve complexity of dependency management, because even if you have 2 targets, then every target should depend on the same target. If you do dependency to another multi-platform library, so it's already 2 dependencies. Also, they need to depend to the common code of other library, and common should depend on other common as well. So it's 5 dependencies only for 2 targets. And that means that if we have even more dependencies, so it's even more complex. So for developer, it will be very noisy to write these dependencies manually. So it should be covered by a plugin for Gradle. So let's move to the instructions about possibility to share code with JavaScript. This is pretty straightforward. You need to extract common things which you exactly want to commonize on server. So you want to share it as a library to JavaScript developers. And this part should be independent. So all the servers will depend on this part, and JavaScript in future will depend on this part. Another thing is that it should be independent from Java libraries, because otherwise you can do it in multi-platform way. In Kotlin, we already implemented different multi-platform libraries like Kotlin HTTP, so you can do HTTP calls inside of it. So if you use some Java libraries, you will be needed to replace them by Kotlin HTTP. You also can do like serialization thing by Kotlin X serialization, and it will be done in the same way on the both client and server. And we also have coroutines, which also multi-platform library, so you can do concurrency in the common code, which will work in the same way on both client and server. But on server, of course, it will be real concurrency. On the client side, you will have like one-threaded code without this callback hell. So now you need to move it into a single multi-platform model to create this Gradle magic, Gradle script, and then generate and deploy this JavaScript library from that. After that, if it's like complete business logic, JavaScript developers will be able to write UI on top of that. And this is the idea that we don't require Java front-end developers to start using Kotlin, because it's very hard to convince them. I mean that TypeScript is pretty nice language, and it's really great. So there is no intention, at least for now, to replace TypeScript by Kotlin.js. But you can simplify things and stop doing different types of bugs for the same code. I mean, JavaScript developers did their bugs, and JVM developers did their own bugs. You can share bugs as well. Originally I wanted to show how to do that in live coding, but I decided to show our showcase, which is full stack application. We call it Kotlin Conf application. So what we have it like two mobile applications, like for iOS and Android. So we have a server, and we're also planning to add Kotlin.js as well as Android web applications. Right now, all the business logic implemented in the common code, and if you want to implement like JavaScript frontend, all you need is actually to create the UI, because all the business logic is shared between iOS and Android, and it actually works. So this is the link to the project. You can take a look for it. It's in some branch, development branch, and in future, of course, it will migrate to master. So if you watch this as a video, so you probably need to check master branch. So let's take a look for this example. Let's go to presentation mode. Okay. I just opened different IDEA, and for some reason it's a bug of go to action action. Do you all know go to action by the way in IntelliJ? This is a very famous thing because you always can do like in console and so on. Okay, so let's go next. Here the structure of the project where we have big build Gradle KTS, which just covers and collects all the project together and dependencies. We have a common part, which is the most important here, backend part, Android application, and iOS app. iOS app completely separate. It's not the part of this project. It has own Xcode project. So we need to build framework from the Gradle and then publish this framework to the Xcode project, and then you can open Xcode and actually build and see the application in action. So what is in common? We have built Gradle KTS, which actually has a description of all this stuff. It's not as simple as we would like to have. It defines all the targets, actually for the all targets I described, like ARM32, ARM64, and X64. And also it defines target for backend and Android, which is the same like JVM target. That's it. And what in common part? Actually, we have a conference data. So this is our model, which can be shared between all these clients and server, and it's serializable in the same way. So that's very nice because you can reuse these objects in the clients in the same way. But what is the difference? Difference is, for example, our dispatcher. So that's what we have, like expect function, which is not declared. So we can use this function in our code, like simple one is generate user ID, but we implemented it in different way on iOS and JVM. So for example, for iOS we have implementation here, and this is like a native calls to UI device, current device, and so on. So we can also take a look for how looks native code in Kotlin. And here you can see that it's also, like I showed you with JavaScript, it's also generated Kotlin Kotlin stubs, something like that. So it looks like the Kotlin code, but it's in reality it's native code. So it's required for Kotlin compiler to see it like a Kotlin code, and IDE see it like a Kotlin code. But in reality, this is just an API of iOS APIs. Here the same thing. All these calls like dispatch time, dispatch after, and so on. So another different thing is dispatcher, which is kind of hack. I mean that for iOS we definitely need to move this implementation inside of coroutines support. Special thing for iOS. So we need to publish special library for iOS, which is coroutines library, and put this all this code to that place. But that's exactly the point. We needed this showcase just to go through all this stuff and to understand problems on this path. And that's why I also tried to inspire people to try this multi-platform stuff and give us feedback because we want to make this as a future brilliant technology and give it to the world to use and to stop doing the same code more than one time. What else here is like UI state, which is also shared in the common codes. So we have the same code, and then on the UI level we can just render activities based from this thing. Another thing is API, which is also used. It uses coroutines and Kotlin HTTP, so we can call these endpoints, server endpoints, in the same way on the all clients. It's in common code and it's also compiled on backend, but of course this code will not be used on the backend here. So what we have here, we can like call API call to favorites endpoint, and at the same moment we on the backend thing we have defined this favorites endpoint. So we can see here API routing for the favorites. So as you can see, it's not the brilliant code because, for example, this string can be shared and not written twice. So it's the usual big mistake to have hard-coded strings. So, but here we can simply fix that. So we can just extract this thing, like put the favorites pass. Because for especially for favorites, it's I really like this word because in British and American English there are different spelling for that. So it's very simple to create error on the client side. And we can just put here. So now we extracted this string, and on the API level we can define this like favorites string, favorites pass, because it's available here from common code. What the problem here is that we still do, like duplication in server and client world. It's very important, very common to generate code for the client. For example, we have API endpoints, so we can generate things. And for example, in some we have internal in JetBrains project, which is fully in Kotlin. It's written in Kotlin everywhere, like fully written in iOS. For React Native, we have a front end completely written in Kotlin JS, and backend is also written in Kotlin. And they exactly do the generation of code for the endpoints. So yes, this is possible. So we just looking for the new paths, and there are different ways to implement these kind of things. So that's it about Kotlin Conf application. So if you have any questions, as I'm working on Kotlin IDE, probably you have such a question, so when it will become faster or something like that. So you probably can ask right now.
I have one question about multi-platform and especially JS. Is there any support for reflection in JS and other targets other than JVM?
So question about reflection in other targets than JVM. Very simple reflection implementations exist in both JavaScript and native, but it's not full reflection as we have on JVM. And full reflection requires quite a lot of work, so unfortunately we don't have it yet.
So by basic you mean, for example, I can list all methods of given class or something more?
I definitely think that you can just get the name of the class, so at least what you can do.
I should also mention that we have a Slido application, so you can all go into the slido.com and type the sphere.it hash. So and then you can ask questions during the talks anonymously.
Anonymously, that's the most important.
Yeah.
But you can put your name as well.
Yes, you can put your name as well.
But if you have more questions without Slido, it's okay. Yeah?
Are you planning to support any other front-end frameworks except of React?
So question is, do we have any plans to support other than React frameworks? So the answer would be, I would say, community can help us to, because so many frameworks exist in the JavaScript world, and sometimes we can do, of course we can call all these frameworks right from the Kotlin as I showed, so it's like interoperable, but in Kotlin you can do it in more nice ways with coroutines and other DSLs, so you can really improve these frameworks. So if you feel like you can help, you can just support famous frameworks, and you can get lots of stars on GitHub because of that. So this, and do lots of talks on KotlinConf and other conferences. So this is a great idea to improve your personal brand. But speaking about popular frameworks, we are trying to support them as well. So because we are doing internal projects as well, React support came exactly from our internal project. So one more question.
And talking about React, are you planning to support hooks?
Hooks? Unfortunately, I don't know about this framework as well as do. I'm a Kotlin IDE guy mostly, and I also behind of multi-platform stuff as well. So JavaScript is just part of it. So I'm not in JavaScript world. So I don't know all the frameworks, unfortunately.
Okay, so we do have a question on the Slido. Is using multi-platform to support different versions of different libraries a good idea?
Different versions of different libraries.
Same level, different version of Guava.
Yes, I think that it's not the good idea. So I mean that it's just how you can think about different targets. Even for example for JVM, different version of JVM. So this is exactly the same case because it's different versions of the same library. But for example, you can like recompile it for different JVM versions because as a result you can get different bytecode version. So you probably could want to publish it in different way. So sometimes it can be a good idea for example for JVM, but not always. But speaking about JUnit and TestNG, I wouldn't say it's a good idea. So it's better to do in different way.
From my experience, IntelliJS only took off really when we got the cross-platform like publishing of libraries, right? So that all the libraries are there, the community rights, and the larger ecosystem of libraries, not just the standard library, then all the authors of those libraries could very easily compile, test, and publish the multi-platform versions of those libraries. That was like literally we saw in the history, like at that point in time, IntelliJS took off. What's the story in KotlinJS with that?
Okay, so the question is about how we are planning to publish cross-platform libraries. Am I right?
Yes.
So okay, we are working on own library format, which is named klib right now, and it will contain backend intermediate representation, which will be possible to additionally compile to any of backends. So it's going to be in very complicated way. I mean that these klibs will be possible to publish as a Maven repository and then just reuse it. And if you don't have some target, you can compile from intermediate representation. So for example, somebody compiled it for few targets, but you lack of some more targets, so it will be possible to compile it locally as a dependency to this. This is important for Kotlin native especially, because if you compile just for JVM and GS, it's pretty simple, but you can lack of some, for example, Windows compilation, because library auto compiled just for Linux and macOS. and you really can do it on your machine because of backend IR. It's all experimental, but it's all on the way. I mean that we have a hard progress on that, and it requires lots of time, unfortunately. But we really want to solve this problem and to simplify for library developers.
Okay, so are there any more questions?